Hi students, I am Sheeba from Emmanuel Research JJ College of Engineering. Today we are learn about the topic Boolean Algebra. First we can see the introduction. It is developed by English mathematician George Boole in between 1815 to 1864. It is described as an algebra of logic or an algebra of two values, that is true or false. The term logic means a statement having binary decisions, true or yes or false or no. Boolean algebra is a system of mathematical logic. It differs from both ordinary algebra and the binary number system. Boolean algebra terminology. Variable. The symbol which represent an arbitrary elements of an Boolean algebra is known as variable. Any single variable or a function of several variables can have either a 1 or 0 value. For example, in expression y equal to a plus bc, variables a, b and c can have either a 1 or 0 value, and function y also can have either a 1 or 0 value. However, its value depends on the value of Boolean expression. Next, we can see the term constant. In expression y equal to a plus 1, the first term a is a variable and have value either a 1 or 0. The second term has a fixed value 1. So 1 is a constant here. The constant term may be 0 or 1. Next term is complement. A complement of a variable is represented by a bar over the letter. For example, the complement of a variable a will be denoted by a bar. So, if a equal to 1, comma a bar equal to 0, and if a equal to 0, comma a bar equal to 1. Sometimes a prime symbol bar is used to denote the complement. For example, the complement of a can be written as a bar. Next term is literal. Each occurrence of a variable in Boolean function, either in a complemented or an uncomplemented form, is called literal. Boolean function. Boolean expressions are constructed by connecting the Boolean constants and variables with the Boolean operations. These Boolean expressions are also known as Boolean formulas. We use Boolean expressions to describe Boolean functions. For example, if the Boolean expression a plus b bar into c is used to describe the function f, then Boolean function is written as f of a comma b comma c equal to a plus b bar into c, or f equal to a plus b bar into c. Next, the application of Boolean algebra. First application is it is used to perform the logical operations in digital computer. In digital computer, true represent by 1, that is high voltage value, and false represent by 0, that is low voltage value. Logical operations are performed by logical operator. The fundamental logical operators are AND gate, OR gate, NOT gate. AND gate is a conjunction gate, OR gate is disjunction gate, NOT gate is negation or complement gate. Next, the AND operator. It performs logical multiplication and denoted by dot. We can see the truth table of AND operator. X, Y are the inputs and X into Y is the output. For 0, 0, 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. Next, the OR operator. It performs logical addition and denoted by plus. Here, X and Y are the inputs. X plus Y is the output. For 0, 0, 0 plus 0, 0. For 0, 1, 0 plus 1, 1. For 1, 0, 1 plus 0, 1. For 1, 1, 1 plus 1, 1. Next, the NOT operator. It performs logical negation and denoted by complement bar. It operates on single variable. X is the input and X bar is the output. X bar means complement of X. For 0 input, 1 is the output. For 1 input, 0 is the output. Next, we can see the truth table. Truth table is a table that contains all possible values of logical variables or statements in a Boolean expression. Number of possible combination equal to 2 power n, where n equal to number of variables used in a Boolean expression. The truth table for xy plus z is as follows. The first column shows the decimal number and xy z is the inputs. In Boolean expression, first operation is xy and the second operation is addition operation. So, first the decimal number 0, the input value 0, 0, 0. For x into y, 0, for x value is 0, y value is 0, 0 into 0, 0. xy plus z means xy plus z value is 0, 0 plus 0, 0. For decimal number 1, the input value 0, 0. xy operation is 0 into 0, 0. For xy plus z, 0 plus 1, 1. Our reset value is 1. For the decimal number 2, xy value is 0, 1. Or x 0 into 1, 0 for xy. And xy plus z, the z value is 0. So 0 plus 0 equal to 0. The decimal number 3, the xy value is 0, 1. 0 into 1, 0. Xy plus z, the z value is 1. 0 plus 1, 1. The decimal number 4, the xy value is 1, 0. For xy, 1 into 0, 0. And xy plus z, the z value is 0. So 0 plus 0, 0. For the decimal number 5, the xy value is 1, 0. So xy 1 into 0, 0. And xy plus z, the z value is 1. So 0 plus 1, 1. For decimal number 6, the xy value is 1, 1. So 1 into 1, the output is 1. And xy plus z, the z value is 0. So 1 plus 0 equal to 1. For the decimal number 7, the xy value is 1, 1. So x into y equal to 1 into 1, 1. And the xy plus z, here the z value is 1. So the xy plus z equal to 1 plus 1 equal to 1. Tautology and fallacy. If the output of Boolean expression is always true or 1 is called tautology. If the output of Boolean expression is always false or 0 is called fallacy. Next, the implementation of Boolean algebra. Boolean algebra applied in computers, electronic circuits. These circuits perform Boolean operations, and these are called logical circuits or logical gates. Next, we can see the logic gates. Logic gates are the basic elements that make up a digital system. The electronic gate is a circuit that is able to operate on a number of binary inputs in order to perform a particular logical function. The types of gates are available are the NOT, AND, OR, NAND, NOR, exclusive OR, and the exclusive NOR. A gate is a digital circuit which operates on one or more signals and produce single output. Gates are digital circuits because the input and output signals are denoted by either 1 high voltage or 0 low voltage. There are three basic gates and are AND gate, OR gate, NOT gate. Next we can see the AND gate. AND gate is an electronic circuit that gives a high output 1 only if all its inputs are high. AND gate takes 2 or more input signals and produce only one output signal. Figure shows the logic symbol of AND gate. Here A and B are the inputs and A into B is the output. The next diagram is the truth table of AND gate. AND gate performs the multiplication operation. Here the inputs are A and B. For two values, the input values are 0, 0, 0, 1, 1, 0, 1, 1. The AND gate performs multiplication. So 0 into 0, the output is 0. For 0 into 1, the output is 0. 1 into 0, the output is 0. 1 into 1, the output is 1. The application of AND gate is, it is used to implement logical AND operation. The Boolean expression of AND gate is y equal to A into B. Next we can see the OR gate. Next, the OR gate. The OR gate is an electronic circuit that gives a high output if one or more of its inputs are high. OR gate also takes two or more input signals and produce only one output signal. The first diagram is a logic symbol of OR gate. Here the inputs are A and B and the output is A plus B. Then next we can see the truth table of OR gate. Here the inputs are A and B. The output is A plus B. For A and B, for 0, 0 value, 0 plus 0, 0. For 0, 1, 0 plus 1, 1. For 1, 0, 1 plus 1, 1 plus 0, 1. For 1, 1, 1 plus 1 equal to 1. Application of OR gate is used to implement logical OR operation. The Boolean expression of OR gate is y equal to a plus b. Next, we can see the NOT gate. NOT gate is an electronic circuit that gives a high output if its input is low. NOT gate takes only one input signal and produces only one output signal. The output of NOT gate is complement of its input. It is also called inverter. Figure shows the logic symbol of NOT gate. Here the input is A and the output is A bar. Next diagram is truth table of NOT gate. Here the input is only one input, that is A, and the output is A bar. For 0 input the output is 1. For 1 input the output is 0. The application of NOT gate is used to complement digital signal. The Boolean expression of NOT gate is y equal to a bar. Next we can see the practical applications of logic gates. First application is AND gate. So while going out of the house, you set the alarm switch, and if the burglar enters, he will set the person switch and the alarm will ring. In the diagram we can use person sensor and alarm switch. If both the person sensor and the alarm switch are on, then the burglar alarm is activated. Practical applications of logic gates. First gate is AND gate. Electronic door will only open if it detects a person and the switch is set to unlocked. Microwave will only start if the start button is pressed and the door close switch is closed. Next, the OR gate. You would of course want your doorbell to ring when someone presses either the front door switch or the back door switch. Here we use the front doorbell switch and back doorbell switch. If either the front doorbell switch or the back doorbell switch is pressed, then the doorbell rings. Next we can see the practical applications of NOT gate. When the temperature falls below 20, the NOT gate will set on the central heating system. Here we can use the temperature detector and the central heating. If the temperature is above 20 degrees Celsius, then the central heating is switched off. If the temperature is below 20 degrees Celsius, then the central heating is switched on. Next we can see the NAND, NOR, XNOR gates. First one, NAND gate. It is known as a universal gate because any digital circuit can be implemented with NAND gates alone. Figure shows the logic symbol of NAND gate. The inversion of AND gate is NAND gate. For AND gate symbol, we can put a bubble, means it is a NAND gate. Figure shows the truth table of NAND gate. For here, the inputs are X and Y, the output is Z. For 0, 0, the output is 1. For 0, 1, the output is 1. For 1, 0, the output is 1. For 1, 1, the output is 0. Figure shows the implementation of NAND gate. For one input, f equal to x into x the whole bar. So that is x bar plus x bar. That is x double bar. It is equal to x. That x double bar equal to x. Next, from the diagram, we can write the Boolean expression f equal to x into y the whole bar and the double bar. So we can write the x bar plus y bar the whole bar. That is x double bar into y double bar equal to x into y. Next diagram, we can write the Boolean expression f equal to x bar into y bar the whole bar. So we can write x double bar plus y double bar, that is equal to x plus y. It is equivalent to the diagram. The application of NAND gate is it can be used to implement any digital circuit. The Boolean expression of NAND gate is y equal to a into b the whole bar. Next gate is NOR gate. The output is high when all the inputs are low. Figure shows the logic symbol of NOR gate. The inversion of OR gate is the NOR gate. Here the inputs are x and y. The output is z. For two inputs, for the input value 0, 0, the output is 1. For 0, 1, the output is 0. For 1, 0, the output is 0. For 1, 1, the output is 0. The application of NOR gate is it can be used to implement any digital circuit. The Boolean expression of NOR gate is y equal to a plus b the whole bar. The next gate is XOR gate. XOR gate means exclusive OR gate. The output is high only when odd number of inputs are high. Figure shows the logic symbol of XOR gate. Here X and Y is the input and Z is the output. For XOR gate, the output is when odd number of ones the inputs, the output is 1. For 0 0, there is no 1, that is output 0. For 0 1, here there is a odd number of 1, so the output is 1. For 1 0, here the odd number of 1, so the output is 1. For 1 1, here the even number of ones, so the output is 0. The application of OR gate is, it is used to implement magnitude comparator, gray code converter, adder and subtractor circuits, parity generator, modulo to adder, etc. Boolean expression of XOR gate is Y equal to A XOR B. Next we can see the XNOR gate. For XNOR gate, the output is high only when even number of ones at the input are high. Figure shows the logic symbol of XNOR gate. Here the inputs are X and Y, the output is Z. For 0 0, here the even number of ones, so the output is 1. For 0 1, here the odd number of ones, so the output is 0. For 1 0, here the odd number of 1, the output is 0. For 1 1, here the even number of ones, so the output is 1. The application of XNOR gate is, it is used to implement even parity generator, comparator, even parity checker, etc. The Boolean expression of XNOR gate is Y equal to A XOR B, the whole bar. Next, the power consumption of system. Basic theorem of Boolean algebra. First theorem, properties of 0. 0 plus A equal to A, 0 into A equal to 0. Theorem 2, properties of 1. For 1 plus A equal to 1, 1 into A equal to A. Theorem 3, commutative law. First law, A plus B equal to B plus A. That is, the order in which the variables are ordered makes no difference in the output. Second law, A into B equal to B into A. The order in which the variables are and makes no difference in the output. Next theorem, associative law. First law is A plus B plus C equal to A plus into B plus C. It states that in the ORing of several variables, the result is the same regardless of the grouping of the variables. A into B into C equal to A into BC. This is the second law. In second law, it states that it makes no difference in what order the variables are grouped when ANDing several variables. Next theorem is distributive law. A into B plus C equal to AB plus AC. This is the first law. It states that R-ing several variables and finding the result with a single variable is equivalent to finding the result with a single variable with each of the several variables and then R-ing the products. Next law is A plus BC equal to A plus B into A plus C. It states that finding several variables and R-ing the result with a single variable is equivalent to R-ing the result with a single variable with each of the several variables and then finding the sums. Next law is A plus E bar B equal to A plus B. Next theorem is idempotence, that is identity law. First law is A plus A equal to A. Second law is A into A equal to A. Next theorem, absorption or redundance law. First law is A plus AB equal to A. Next law is A into A plus B equal to A. Next theorem, complementary law. First law is x plus x bar equal to 1. Second law, x into x bar equal to 0. Next theorem, involution. X double bar equal to x. Next theorem, De Morgan's theorem. X plus y the whole bar equal to x bar into y bar. Next law, x into y the whole bar equal to x bar plus y bar. Next we can see the De Morgan's theorem. De Morgan suggested two theorems that form an important part of Boolean algebra. In the equation form they are: first law, A into B the whole bar equal to A bar plus B bar, that is NAND equal to bubbled R. The complement of a product is equal to the sum of the complements. Figure shows the equivalent logic diagram of De Morgan's theorem 1. Here the truth table verification of De Morgan's theorem 1. For the input here, the inputs are A and B. For AB bar, the input 0 0, the value is 1. For 0 1, the output is 1. For 1 0, the output is 1. For 1 1, the value is 0. So the A bar and B bar, for A value the output is 1. For B equal to 0, the B bar is 1. So A bar plus B bar equal to 1. For 0 1, A bar plus B bar equal to 1. That is A bar equal to 1. For B bar equal to 0. And for A 1 0, the A bar equal to 0 and B bar equal to 1. So A bar plus B bar equal to 1. For 1 1, the A bar equal to 0, B bar equal to 0. For A bar plus B bar equal to 0. Next, the De Morgan's theorem 2. A plus B the whole bar equal to A into B, A bar into B bar. The complement of a sum is equal to the product of the complements. The equivalent of theorem 2 nor equal to bubbled and. Figure shows the logic equivalent of theorem 2. Next, we can see the truth table verification of theorem 2. For 0, 0, a plus b the whole bar equal to 1. For 0, 1, a plus b the whole bar equal to 0. For 1, 0, a plus b the whole bar equal to 0. For 1, 1, a plus b the whole bar equal to 0. For a bar into b bar, 1, 1, a bar into b bar the equal to 1. For 0, 1, a bar is 1 and b bar is 0. A bar into b bar equal to. For 0, 1, the a bar is 1, b bar is 0. So a bar into b bar equal to 0. For 1, 0, a bar is 0 and the b bar is 1. A bar into b bar equal to 0. For 1, 1, a bar is 0, b bar is 0. So the a bar into b bar equal to 0. So the truth table column of a plus b the whole bar equal to a bar into b bar. Next, the application of De Morgan's theorem. De Morgan's theorem is useful in the implementation of the basic gate operations with alternative gates, particularly with NAND and NOR gates, are readily available in IC form. Next, the principle of duality. The principle of duality theorem says that starting with a Boolean relation, you can derive another Boolean relation by changing each or sign to an AND sign, changing each AND sign to an OR sign, and next the complementing any 0 or 1 appearing in the expression. For example, dual of relation a plus a bar equal to 1 is a into a bar equal to 0. Here, the NAND and NOR gates are known as universal gates since any logic function can be implemented using NAND or NOR gates. For NAND gate, the NAND gate can be used to generate the NOT function, the AND function, the OR function, and the NOR function. An inverter can be made from a NAND gate by connecting all the inputs together and creating in effect a single common input. An OR function can be generated using only NOR gates. It can be generated by simply inverting output of NOR gate. Finally, we can conclude the topic Boolean Algebra. So, thank you for So thank you for all.